Hi. We are, this is the video for chapter 2, lesson 1, day 2. So we've got vertex forming of a quadratic function. And today we're just delving a little bit deeper. We're going to do some word problems and talk about standard form and what that looks like. So yesterday we did this vocabulary as well, but a parabola is still the U shape that a quadratic makes. A quadratic function means that there is an exponent of 2, a squared, okay? All this is still the same because it's still important. I wanted to include it. Basically, your A talks about whether it's going to be narrow or fatter. That's a stretched or compressed. So check this out, compressed, stretched, right? Okay. My H is always the opposite sign of the number, but that is what I use for my axis of symmetry. And in my vertex, it's my H value. My K, H also tells me if I have a left or a right shift, shifting right, shifting left. The K tells me whether I shift up or down. The K, that we call that a vertical shift. In the vertex, my K is the second number in the ordered pair. All right, let's get started. The height of a thrown ball is a quadratic function of the time it has been in the air. So the two are correlated. The longer it's in the air, you could say that the higher you threw it, okay? The graph of the quadratic function is the parabolic path of the ball. The vertex of this graph is 1, 20, and the path of the ball includes a point 0, 4. What is an expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. That's called standard form. And by the way, there's a couple things I want to point out. This 4 right here, this is how high the person is that's throwing it. Because if I'm standing there and I'm about to throw a volleyball, the beginning point of the volleyball is how high my arms are and my hands are. So if I serve it, right, then I'm here, this example, the person serves it at a height of 4 feet. Because you never start from the ground, like you're on the ground and then you throw the ball. No, you're standing up, however high the person is, and then you throw it and you serve it, and it's like 4 feet high off the ground. So maybe this person's even shorter, but the beginning height of the volleyball is 4 feet, okay? So here's what we're gonna do. I'm gonna use this information like I did yesterday. HKXY, here we go. 4 equals A, I don't know what A is. 0 minus 1 squared plus 20. Then I'm solving. 4 equals 1A plus 20 minus 20. I'm running out of space. Anyways, A equals negative 16. So here is my vertex form of this word problem. Y equals negative 16 x minus 1 squared plus 20. So there's vertex form, done. Vertex form, VF, if you need that. Standard form. Standard form just means that I still want my y on the left, but I got to get rid of this squared, which means I have to FOIL it. So let me show you the work. I'm going to do x minus 1, x minus 1. Okay, I'm going to worry about the 20 at the end. Worry about that 20 way at the end. X minus 1, X minus 1. Let's do that multiplication. X squared minus 2X plus 1. Okay, so then I'm distributing negative 16x squared plus 16 times 2, 32x minus 1 times 16, 16 plus 20. Almost there. Y equals negative 16x squared plus 32x plus 4. So here's standard form. Standard form. Then it says, why does the ball start at a height of 4 feet? Because the person is 4 feet high. We could say that person is that high off the ground, or the ball starts in the person's arm, or the person is approximately 4 feet tall. Okay, again, if you need to pause during this video, please pause, that's fine. Okay, otherwise, let's move on. All right, challenge problem. I don't really think it's a challenge problem for you, except for the fact that it has fractions. Don't let that bother you. The vertex is still HK. That's gonna be 3/2, 3/4. Let me zoom in. Oh, so much better, you guys. My axis of symmetry, the x value of my, and by the way, if I really had to graph this, I wouldn't go 3/2. I would go 1.5, wouldn't I? Over 1.5. Because 3/2, you have to change it to a mixed number. So x equals 3/2, but again, we know that that would be 1.5 if I actually were drawing my dotted line. This is a negative sign. That means that the parabola faces downward, and that means that it has a maximum because my parabola faces downward, right? If my vertex is like here, it'd be like that. That would be my parabola. So the maximum is at 3/4. Okay. My domain is going to be all real numbers because the domain for parabolas is always all real numbers. And my range goes low to high, negative infinity all the way up to the top point where it maxes out, which is 3/4. So that's my range for the function. So I don't know that this is a challenge. I think that you guys, dealing with fractions is just fine. Okay. Definitions real quick. We did this yesterday, but my vertex is my turning point. My axis of symmetry is x equals h. It's also my dotted line. It's my line of symmetry. It cuts my parabola in half. Cuts is not the proper mathematical word, but it's a dotted line that goes down the middle of the parabola. Max or min depends on if it's upward facing. It has a maximum if it's downward facing. It has a minimum if it's upward facing. Domain for parabolas is always all real numbers. But for the range depends on if it's upward facing or downward facing. So that kind of is like dependent, but I can say that it still goes from low, comma, high. And there's always going to be infinity somewhere in this. All right. My, hold on, I have to pause for a second. Hi. My son came home and I thought it'd be fun to put on a hat. I have all these hats, so I'm going to be a cowgirl for the rest of the video. Hope you don't mind. Okay, so where am I? We are going to do number 4. The function of g, blue, is a translation of the parent function f. 1 unit left and 3 units up. What is the equation of g? Write the quadratic equation in vertex form and in the form f of x equals ax squared plus bx plus c. So I know that this is going to be, first I'm going to check, like do I go over 1, up 1? Over 2, up 4? Over 1, up 1. Yeah. Over 2, up 4. 1, 2, 3, 4. Yeah. That means that A is 1. Here we go. A is 1. Don't put a 1. My vertex is 1 left. Oh, I don't want to do X. 1 left, 3 up. When I put that though for my X minus H, it's going to be X plus 1 squared plus 3. Okay? Good, good, good. Now standard form. Here we go. Just FOIL the X plus 1, okay? Right? X squared plus 2x plus 1 plus 3. So g of x is going to be my translated in standard form. Actually, this should be g of x too, because it said, what is the equation of g? F of x was this, x squared. G of x is my translated. 1 to the left, 3 up. G of x, standard form. X squared plus 2x plus 4. Awesome. How were you able to determine the A value? Well, I personally was able to just use my parent function information and count. Information or my background knowledge about the parent function. If I didn't know, or if some reason it wasn't over 1, up 1, over 2, up 4, here's what I would have done. I would have used, here's an alternate method, used my -1, 3, my H and my K, and a point on the graph. It means I would have had to pick a point on the graph of G. Here's one. My y-intercept, guys. My y-intercept is 0, 4. XY. To plug in H, K, X, and Y, then solve for A. So that would have been my alternate method if the G of X, if the blue wasn't kind of like a perfect looking over 1, up 1, okay? So in class, we're going to do try it 4 and 5, and then there's a Pearson assignment. So we're gonna do all that in class tomorrow. So your only job right now is to take notes, and that's it. Awesome. Okay. I will see you guys in class tomorrow. Bye.